Thank you, Martin. It's like super warm welcome. Like I'll try to keep it up by like in a sense living up to the expectations. And yeah, like I don't know, I like the event. It's like amazing cozy feeling. So thank you guys for organizing it. And let me bootstrap with this kind of broader discussion. It will not specifically about like product or something. It's like guys, where we are living through, like what happens around. In this case, like a few words about me, in a sense, like for those who don't know. So being part of a blue team, being part of a red team for several years, heavily in InfoSec, but maybe last 5 years, switching to AI a lot. We could seen the kind of potential coming even before LLMs. Yeah, work in Microsoft, work in Avast, right now in Ale from the first days. And talked at Black Hat, DEF CON, so like quite an experience. So let me share you what I see at least happening. In Ale, we kind of, I believe, grow a team from like few folks to the 60 right now. So we kind of see what works, what not, what the skill set that people possess has a potential, what's maybe not needed as we go on. And like all starts with the paradigm shifts that we all of us observe in last, I don't know, like 6, 8, 10 months, which is, I don't know, every one of us feel it, but I will explicitize it. Then the skills that actually like we have to preserve, some of them become obsolete, some of them actually become more valuable. And then we'll dive specifically to more cybersec applications, how this like is valuable. So seismic shifts. What do we see? I believe, like before, who of you knows what this subcommand would do? Like, if I type this, nice, I like to see. Guys, congrats, like we possess some non-relevant knowledge anymore, right? It's like, because this can be done with something like this. And, yeah, it's like what to do about this, right? I don't know, for some reason, this is stuck in my head that I can do it that way. But I don't really need it anymore. And this is like observation number 1 that we have, is that knowledge shelf life kinda goes to, I don't know, like where it goes. So like, do you invest in learning something? Do you don't? How deep you go for stuff to kind of teach yourself? And this applies to many things. I don't know, like it's not specific example. Like it across the fields. Do you need like to know some details? I will argue about that, but it's kind of first observation, right? One of the examples from the AI world, like again, I now shift heavily towards AI, how to use agents, how to make them useful for others. One of the observation that we see, or like people say, that harness is that. What's harness? It's kind of this complementary engine around the model. For example, it's like set of skills, instructions that you give to the model, or it's a wiring of different agents together. For example, Anthropic has this amazing blog post called Building Effective Agents. It has so many kind of architectures, how you can wire them together. For example, this approach with a main agent and then critic agent is something we used kind of in prod heavily, but then we've seen it become obsolete. And that's back to the point of like knowledge shelf life. So many things that we learn kind of become non-relevant just after a few months, because kind of models themselves become better and better, clever and clever. And basically 2 weeks ago, this guy, who knows this guy? He called, nice. So like Carlini is super like prominent person. If you don't know, I kind of advise you maybe to follow his research. One of the main kind of people in the intersection of AI and security. So he basically said, guys, like we don't have harness at all. That's all our harness. We just give it instruction, and model is so good that it solves the tasks. And I don't know. So harness is that? Maybe not. So I don't know. The thing is, there's another evidence that it's not that. Like, for example, Cloud Code leak 2 weeks ago. If you see, it's like such a heavy system. It uses so many memory mechanisms, different approaches. So like the harness is still important. And that's what we see as well in Ale. For example, Stan published again how just model is not enough. There are so many things, and we believe the system is the ultimate still like paradigm mode. So again, so many things changing so fast. Another observation, slope is everywhere, right? I don't know if you open LinkedIn page, like, I like this blog post by Florian Roth. He basically said like, hey guys, these are the like, I don't know, categories where detect slope right away. I know, like, this is not opinion, this is math. It's not a feature, it's a paradigm shift. Like, not hype reality. It's like when I open LinkedIn, I see it, I don't know, every second blog post has something like this. And like, I feel myself as a playing Minesweeper here, right? It's, do you invest in reading this stuff? Or like, it seems legit, but after you read it for 10 minutes, you feel, okay, that was empty stuff. So like, you hit a mine. But some of the things are still relevant. You want to keep like consuming information that's valuable. And, yeah, it's tough. And, observation number 3, it's that code is cheap. Like, for now, producing something, it's so easy. And no, like, you can wipe code UI just for your needs in like, I don't know, 30 minutes, 2 hours. I've seen folks that created like ticketing system just for themselves for this specific task that they are using, and like it works nicely just for them. And yeah, this has some interesting consequences. This is a chief operating officer from GitHub. He says, like, guys, we had 1 billion commits in 2025. This year, like, we're having 250 millions, like 25% just a week. And they expect like 14 billion commits in a whole year without like any expectations on rising project. Like, that's wild. Like, people coding so much thanks to agents. And, yeah, this resulted in kind of an emergence of so-called, I call them empirical coders, is when you kind of prompt, you run stuff, you observe results, and you prompt again, and you just keep loop. And you basically kind of don't really understand what happens under the hood. You kind of don't read code sometimes, maybe. And it's kind of, we might say, dude, like, what you're doing. But the truth is, actually, we don't know. Maybe it's a winning strategy. Maybe, like, one thing this allows to iterate as fast as possible. You can, like, clap on ideas super, like, really, really quickly. And the thing here is, again, to figure out when you have to go deep, when not. Another interesting observation that it enables non-coders to create. I've seen product managers creating amazing kind of prototype solutions that you can take and like expand on. One of the examples, for example, this CEO of Y Combinator, basically VC group, and he started maintaining a library just like from this year, January, thanks to this. And that's amazing, I believe. It enables so many people to kind of create something, to build that can manifest in a good solutions. So, given these 3, significant observations, like changes how we do stuff, at least it's so significant. Like for us, in a moment, we kind of lag the trajectory. We have to zoom out and see that this really changes a lot. So, what are the skills that survive these, significant shifts in how things happen? I'd say, one is back to the point of this empirical coder. When do you actually decide when to go deep? And I like this kind of type of memes, or like, it's my favorite, I don't know. But this applies to this right level of abstraction really well. In a sense, like, the naive user can say, like, I just wipe code. Then majority of us thinks, no, the AI needs our guidance. But like, the most enlightened one says, no, come on, just let agents do it. And that's example of maybe Karpati as well, kind of trying to push some of these ideas, of course, not blindly, not radically, but saying that sometimes we, as a humans already in this age, in the implementation space, we are kind of bottlenecked. For example, one of his latest creations is basically auto research prototype, or like where he kind of proves that if you feed agents towards a well-defined metric, which is a validation loss, they actually figure out techniques that he wouldn't come himself with, like how to optimize further. In this case, it's in a small GPT model. So yeah, and I would say this, like, generally broadly, it falls under category of like skill set of tech lead. In this case, it's kind of tech leads know when they have to trust and delegate, both humans and agents. You can ask, hey, create this and I will not interfere with you. Just produce me results. And again, this can work with humans, but so more and more this works with agents. And you kind of have to trust them in a sense to create stuff. And you kind of, when you need, you go deeply. At the same time, as a tech lead, you still possess a broad knowledge that's deep enough to allowing you to think about the the concepts. That's why the things that we discussed in the beginning, Nmap or like SSH and like others, are still relevant because they allow you to think about this thing. Like, you have to know that SSH can do tunneling in order to like reason about, for example, attack chain. So, and this applies to basically any domain you're expert. I don't know, like reversing, SOC and stuff. So like, it's still worth investing in fundamentals. And, back to the point that you can float on a higher level of abstraction, but when it's needed, you can go deep and solve it all the way to the like crux of the problem. Second skill I'd say that is like distinguishing is the taste. And it's kind of often not answering how to do things, but what to do, right? Usually if you have a good taste, then you kind of pick problems that matter, or approaches that will lead to solutions. And if you don't, like, of course it's radicals, it's always a spectrum, but, you may spend months on something that is not relevant to the industry, to the company. And, or for example, you pick a method that will eventually not work. It's not the best to work on this problem. Let me show you two examples of a good taste and a bad taste, both coming from me. So in this case, one of the good taste is, for example, I had a talk on B-Sides New York, last October actually. And these are kind of slides from my talk. Is actually, hey guys, the code and language automation. And back at the time, it wasn't still such a big deal. We've seen, like, for example, Sonnet 3.7 doing stuff, but not so autonomously. But already, it was a feeling that, damn, supply chain attacks become a problem. The whole ecosystem is not ready. And we see more and more threat actors automating their modus operandi in this space. And, basically saying, hey guys, we actually detected a few of these things, applying quite easily, and like, it will become worse. It was October. And then in November or December, we've seen this second manifestation of Shai-Hulud, which like compromised thousands of NPM libraries, right? It's like CrowdStrike and so many. And now, Team PCP basically rampaging around. Works? Yeah. Light LLM and, 3V kicks just yesterday or day before yesterday, right? We had the second compromise of checkmarks libraries. No, it's wild. And I don't think this will end soon because they are sitting on so many tokens right now. It's just a question when they kind of weaponize the next wave of the existing accesses they have already. So, and the problem is not users. The problem is not, I'd say, checkmarks or Aqua security with 3B, is the whole ecosystem. It's really not ready. The only way to protect is like pinning the hashes, and that's it. And a lot of people dismiss this as non-relevant, and so it's like having an Active Directory ecosystem in 2010, right? Like hashes are flying everywhere in a network. You just pick them and use them. So like so many protections still should be added to kind of make this ecosystem richer. And again, good taste here resulted in a good kind of direction for Ale. For example, we preemptively started working on the module that would detect, not scan only first-party code, but third-party code, and consider a supply chain attacks in your dependencies. And that's kind of a module that we are already rolling out for the first early adopters. And I feel the good taste here allowed to be kind of preemptive in this rise of threat attacks. Second is maybe a bad taste, and back to the, reference that Martin made in the beginning, talking on the first B-side, actually talked about kind of pre-training a malware detector with the GPT-like style. And it was resulting in this small language model. So, and back in a time, people thought, damn, small language model can conquer out the large ones. For example, significant people in the industry like Clem, who's CEO of Hugging Face, or LeCun, who invented CNNs, they kind of basically said, in a sense, hey, in 2024, smaller, cheaper models will be used for 99% of AI tasks, which in hindsight, we obviously say, no, it's not. And I believe it's kind of bad taste, or maybe, I, for example, invested time, created this nice malware detector, or published the paper, but it kind of is not resulting in anything, right? Maybe the world is not ready to adopt those small language models. Maybe it's not a valuable direction at all. And in this case, it's how do you actually invest in and train a good taste? And I believe there are multiple directions where you can kind of systematically explore to make your judgments better. One is, again, back to fundamentals. Like nowadays we feel ourselves, do we have to invest in like, I don't know, learning linear algebra if you want to dig into AI? Or do you learn a networking stack like those TCP, UDP, OSINT layers, like OSI layers? And, yes, you have to invest because this allows you in your mind, the elements, the atoms to pick and chain thinking. And that's why you have to know those kind of fundamentals, at least on some level of abstraction, maybe not all the way down, but at least to kind of what they mean. What is a sysmon? What it events look like? Again, for NPM, what are pre-install scripts? What are post-install scripts? And this allows you to think in terms of threat metrics and stuff. Second direction is, you have to read a lot. And, in the current world, it's both shallow and deep reading. Shallow because, right, the observation number 2, slope is everywhere. You want to filter this thing out. Like, don't spend your time on this. It's like, you can spend, like, it looks legit. It looks good unless you read 20 minutes and figure out that it doesn't teach you anything. So you have to have the shallow reading to kind of filter this out. But then when you find that those, like, gems, then you go deeply, especially if it relates to your topic from a good author, from a touching really good, like, cruxes. So go deep, understand the gaps. And this allows you to feel where's the status quo, what are the weaknesses in the current, ecosystem. And then, this gives you this taste. And the last one, that's why these events are amazing. Talking to people, asking questions and listening to what they say. Because, like, you have so much awareness as you can. And other people have their own kind of bubbles they live in, and figuring out what happens in their lives is basically representing, touching the cybersecurity world and like feeling. So these are kind of 3 directions that I would advise to kind of deliberately invest, to have this good taste in a world when agents can do everything for you. And maybe the last one more mundane, but I think this actually distinguishes actual results. And the most, the coolest part, the agency is something that you don't have to, have to 10 years in Meta. Like, I've seen people coming out of universities having high agency, being amazing, like, collaborators. They're the best people to work with because they have this amazing high agency and they can make it happen. They don't care. In a sense, they dig deeper, they understand, like, they can filter out the 3 other, like, tasks on their list. They can prioritize properly, do a proper time management, and deliver stuff. Deliver a good PR, deliver a good feature. So I know this is something for you, like, not to make excuses for yourself. If you want something happen, that can happen. And, like, it's only in your hands. So, like, how do you kind of apply all these, like, shifts and what matters into specific use cases? Let me talk about not test-driven development. It's actually 10 years ago. Evil-driven development, right? That's thing of today. And this is how you actually develop an agentic style, or like anything. Basically, whenever you use agents for something, it can fall paradigm of evil-driven development. Let me show you on a simple case. Like really simple, 0-day discovery with fuzzing. It's like super simple topic, right? And which is like sarcasm. Yeah. But if you take a code and the goal of the fuzzing is to produce a bug, right? Or like, that's one of the ways to do this, leading to some vulnerability. But how conventional flow does it is that you take a human who writes a harness or like seed and a build. It's basically a components needed to bootstrap a fuzzing. And then you feed this into a fuzzer, which then like runs for many, many hours or days, like smoke is coming out of your machine. But then finally it spits out, okay, I have a crash. That's probably something worth attention. Explore it. And what you do is like, or like people do in many directions, specifically with fuzzing, you plug an agent for you to generate these things, right? Just observe it. But and what are the problems arising? You kind of figure out, okay, I want to tweak the system. Okay, it still kind of is good, but I want to tweak it more. Okay, I like ask, please, God's sake, produce a good harness for me. Like you create version 1.2 and like, how do you know whether it helps, whether those tweaks result in something? And that applies to any problem with the agents. It's like whether like do you solve, I don't know, some reporting? Do you solve some, I don't know, scraping? Anything that like AI component, non-deterministic component is used for is like, how do you know if you tweak system and it helps? And that's where evals come in. So you plug basically inputs, outputs in a well-defined scope. You define, for example, and they call benchmarks or evals in the public space. And you say, okay, inputs here are source code and target logic that I want to fuzz. And the outputs here is, for example, coverage that I use, that this set of settings produced result in, or like any bugs. And you keep iterating through this, and you keep running these experiments, and you see these results, like the amount of coverage and bugs. And if you tweak something and it increases, this means it helped. If not, it doesn't. And for example, let me show you an amazing example we did here with Luigi. We took a well-defined project that has fuzzing harnesses, and like has over thousands of them. And so what we built, we took a human-generated harnesses. In this slide, it's gold ones, and the LLM produced, it's like generated. And take a look at this example, for example. Gold line, human-produced, results in 20% coverage of lines in a code base, but LLM-produced harness results in 39. So like it bumps so much the coverage of this fuzz. So you see right away that, okay, this one was a good example. Another one here for the like if-else conditions it reached. It's like 4,000. Here you get the 10,000 of like with LLM generated. So it kind of surpasses the human level produced results, so heavy. But at the same time, you can take a look and, for example, some of them are failing, or like others are like super poorly. And here you can feel, okay, why they fail, how to improve. And in this case, so we floated on quite high level of abstraction before, but for these cases, okay, I have to go deep. And that's where your deep expertise matters. And again, back to the code is cheap. Luigi coded a viewer just for himself to kind of compare two harnesses and see like deeply enough what happens, why it fails, and how to tweak system further. So yeah, that's kind of crux. I believe that a lot of well defined kind of AI applications are needed. Is like, how do you develop it to become better? Is like you use this approach, you define a quick, like fast eval, 12, maybe like 12 examples. You don't need hundreds, 10, 12 examples, and you iterate over them quickly. You see results on many cases at once. You see when they fail. You understand weak points of your system, and you can add examples as you go, like you solve them one by one. And on those cases that matter, you can dive deeply. Maybe second thing that is kind of applies to any problem that you solve with agents or with AI is that everything is a context problem. And I like to think about this in the terms of example of this, like thinking experiment. You have this dude who is president of unnamed country. He's sitting and thinking, should I invade another unnamed country or like attack it? And basically answer is never in his head. Answer is always in the papers that in front of him. Like the intelligence officer comes and puts all this information, amount of troops, where they're residing. And the answer of like whether success will happen or not is in intelligence. It's like, and in this sense, it comes to anything. So for example, problem we are trying to solve in AL is like, hey dude, do you think this CV needs attention? And then, okay, like you send it to your security analyst. That's a tough question. So he thinks a lot. And what he consumes, obviously code base. You see where the vulnerability lives, its reachability, maybe context part of it. But then it's never the code base. It's always something else. So if you have a CV, you check maybe public sources like sysacavs, like GitHub. Does it have exploits? Then you maybe check your infra, like where's the application resides. Obviously, it's in many cases in your head already, but it got there somehow, right? From some sources, and agents have to get this information somehow. And back to the notion, it might be, I don't know, wikis, like ticketing systems, like anywhere that information that's answering this question matters can be added to the solution space. And the subtlety here is to not add a lot. It's actually adding what matters. So you have to filter the noise, and it's kind of having a good context hygiene. It's like filtering really non-relevant pieces, amplifying relevant, and this allows you to kind of solve an issue. That's at least what we're trying to solve with AL now. But it applies again to any domain. I don't know, whether it's reversing with agents, network, I don't know, detection, triage, or something. It all matters on a context that you put. So, like, these are ideas that kind of I see, or like the observations that matter today, the skills, the solution space. Well, it matter next year. I don't know. In this case, the things like the most frightening part for me is that things move so fast. It's so like keeping the pace is kind of hard. And we are actually in this moment when AI can do a lot. They a lot of better than us experts on some domains. They still miss on others. And like soonish, like they obviously will become better. Whether we will reach this last stage, I don't know. But at least kind of we see from some good sources, from Matter, that length of tasks that the AI can do doubles every 7 months. I believe that the skill set that we defined, basically taste, being a technical lead, having high agency, will survive no matter how good agents are. These are like so fundamental to any task delivery that they will survive. But still, I don't know, guys. And for example, I wanted to put like where we are in cybersecurity, having like Opus solving some tasks on like exploitation, but not really, for example, reversing. And it was like, I created presentation 2 weeks ago, and back to the point that things move quickly. They released a new plot with the Mythos now, and basically Mythos is cracking kind of some reverse engineering tasks end to end. And I don't know, yeah, like we probably will get this amplitude much higher. And yeah, where we will in 6 months, in 1 year, we'll see. Like we have to be vigilant. And although I think this is amazing advantage for us, although this gives some benefits to threat actors, obviously even more than defenders. And just kind of as a light reading for the 3 evenings is this AI 2027 creation. And it's actually by good sources. The guys are like ex-OpenAI researchers and stuff, and they wrote the article a year ago, 3rd April 2025. And they predicted, so by May 2026, so basically now, we'll have reliable agents. Back in the time, agents were garbage. They produced something one time, they didn't produce another. So by this time, we'll have reliable agents. And kind of hacking capabilities will approach human professional level. And I would say they are approaching. If you drop a cloud code in a network and say, hey, dude, explore it, report me findings, it will actually do a kind of decent pen test report for this, for example, case. Of course, it's like limited, so it's not really there. That's what they say as well. But the thing is, again, they for October 2027, according to their estimates, the things will go wild. I don't know, it will be super asymptotic. You will get a superhuman researchers, and yeah, I don't know. So far they were being accurate. Where we'll be in a year and a half, if they're still accurate, I don't know. So it might be something like this, right? So, and back to the topic, back to the main topic. I imagine, if you had a time machine, dropping back in a time to, London 18 something, and going over the street asking people, hey dudes, how is it living through industrial revolution? It's amazing, guys, you'll come with medicine, but you'll come with so many things. And people would say, come on, we want to destroy these machines. They're taking our jobs. And, I would say, let's not be pessimistic. The thing is, we are living through a cognitive revolution right now, and that's us. That's us right now, yay! So you don't have to have a time machine to feel this, and but it feels for me like this meme on the right. It's like, damn, it's unstable. So living through revolutions is not easy. So many things change so fast, so quickly, and yeah, let's see what happens. That's it. Yeah.